In this video, we are going to discuss about one of very basic experiments in optics, which is calculation of focal length of a convex lens. The setup is such that it can be done at home. You can already see a demonstration of this setup is already there in the form of a video. Today, what I am going to explain here is how to take readings from this setup and get to know the value of focal length. So this is a very basic setup. You can see here this yellow drawing is for a torch. This torch is put in a box for which opening is of a shape of an arrow, which you can see as real and inverted image being formed on the screen with the help of a double convex lens. So aim of this activity is to find focal length of a convex lens. In order to do this, we have to measure object distance and image distance. So our object image relationship is given by 1 by u plus 1 by v equal to 1 by f. If we do some arithmetic operation and incorporating the formula for magnification, which is v by u, we get our final expression as one by m equal to u by f minus 1. So if we compare it with a straight line equation of y equal to bx plus c, b is slope of the line and c is the intercept. If you compare the two, you can see that if we plot the graph of 1 by m on y-axis and u on x-axis, what we will get is minus 1 as intercept ideally, and 1 by f will be slope of the line. So f will be our inverse of slope. Let's see how to take readings. In order to take readings, it is advisable to take 4 diminished image reading and 4 magnified image readings. You can see from the image formed on the screen whether it's magnified or diminished. Why it is important that what we are plotting is the inverse of m. So if we take from very diminished to very magnified image, we will get a full range in m, which will result in a full range in inverse of m. So it is easily we can get a range for m typically from 0.3 to 2.0. Also, while doing the above step, always include some value where m is nearly 1. That means magnification 1. If you are using it with a candle, it can be little tricky because you cannot measure the flame exactly. But if you are doing it some object where you see the image size is approximately equal to the object size, that's what will give you magnification as 1. Unfortunately, the data that I am going to show, I don't have m which is close to 1. So these are my readings for the experiment. I have varied the value of u and got different values of v, where I got a sharp image of my object on the screen. M is v by u, so we divided this v column by u column and got the value of magnification, and inverse of magnification we are going to plot. Whenever magnification is more than 1, it's a magnified image, and wherever it is less than 1, it is diminished image. So that way, if you see, out of 7 data points, I have got only 2 magnified and rest 5 are diminished. A good data set, what I will call, can comprise of total 9 readings, 4 diminished, 4 magnified and 1 approximately close to 1. So because it's a double convex lens, all the images formed on the screen are real and inverted. So this is the graph which I have plotted using a software called veusz. When we are changing the object distance u, image distance is the result of that, and in turn it will change the value of m. S best fit is given by 0.025 7. So let us calculate focal length. Get some room to write. Yeah. So focal length F will be equal to 1 upon 0.0270, which will come out to be, this we are calculating in centimeters, right? So it is 37.0 centimeters. This is from the graph. Okay. Thank you.